A year ago, we were clearly focused on scaling the learning curve of mercury monitoring with sorbent trap systems, trying to make them work for the utility industry in time to meet the 2009 CAMR deadline. Of course, as most people know by now, this path wasn't quite as straight of a road as we thought. Indeed, without CAMR, the question can certainly be posed, is there life for a long-term sorbent trap monitoring system after CAMR, and does that road still pass anywhere close to a power plant? I'd like to acknowledge Clean Air's two main partners in generating most of the data that I'll be showing today, namely SKC for providing the sorbent traps and Console R&D for analyzing them. I plan to spend a few minutes refreshing everyone's memory as to where we are now with respect to mercury monitoring using sorbent trap systems, how we got here, and where it looks like we may be going as we look down the road. The bulk of the presentation, though, is going to be looking back at the last year or so and discussing some of the progress we've made as we worked our way up the learning curve of these systems. The hope, of course, is that we've learned some lessons that will help in using these systems in whatever application the future holds, with or without CAMR. You probably know that the 2005 Mercury rule required utilities to monitor mercury emissions from their stacks beginning January 1st, 2009. And that there was a provision under Appendix K of Part 75 to use sorbent trap systems in lieu of continuous instrumental monitoring. Likewise, you probably also know that the federal court struck down CAMR in February of 2008 as unlawful because it did not impose mandatory strict controls on mercury pollution for large power plants as the Clean Air Act requires. Of course, CAMR did not go quietly into that good night, and we spent most of 2008 awaiting the news of the next petition or appeal or whatever other legal tactic that only seemed to cause even more confusion. By the end of the year, though, it looked pretty certain that the rule was down for the count. Nevertheless, the Supreme Court ensured that at least a little cloud of uncertainty would still linger into 2009 by granting a deadline extension until the next administration could move in. Meanwhile, many states that had their own versions of CAMR moved on. Examples include Massachusetts, whose old rule actually required monitoring began in 2008. Indeed, Clean Air installed 3 sorbent trap systems for Dominion's Salem Harbor facility, and they've been in operation since early last year. Some states, like New York, incorporated monitoring provisions from CAMR into their own regs and started requiring emissions to be monitored January 1st this year. Other states have monitoring requirements that are further down the road, such as Michigan, that requires systems to be running by 2012. Then again, there is a chance that the Pennsylvania Commonwealth Court changed everything in late January when a judge ruled that PA's own version of the Mercury rule was unlawful, invalid, and unenforceable, given the fact that the federal rule had been vacated. This rule has already been challenged by the PA DEP. If the ruling sticks, though, I'm sure we'll see ripple effects in the very near future. Given all of this, it's hard not to see that the writing may be on the wall for the utilities to have to deal with MACT in the foreseeable future. Indeed, just since December, there have been several precedents pointing in this direction, such as Duke Energy's ruling finding that the vacatur of CAMR means new and recently built power plants require case-by-case MACT reviews, or the agreement by Energy Future Holdings, formerly TXU Corp., to meet MACT for mercury emissions on 2 coal units it's building at Oak Grove, and that plant's under construction already has air permits from TCEQ, or the complaint that it was filed by 12 groups in federal court to see the Obama administration fulfill the Clean Air Act by controlling mercury pollution from coal-fired power plants within 2 years of taking office. And finally, a January 7th EPA memo which asked for MACT consideration when reviewing new plant permits. This will affect all new plants and those that started construction or reconstruction between March 29, 2005 and March 14, 2008. Amidst all of this uncertainty, however, there are some plants that, for one reason or another, have pushed forward with mercury monitoring. I'm happy to be able to be here today and share some of the experiences that we've had in this process. Clean Air has installed and started 30 sorbent trap systems since 2007. 5 of these systems are operating and reporting emissions data for agency compliance purposes. 8 systems are scheduled to begin reporting later this year. And we have 13 systems out there being used to gather baseline data. Only 4 systems that we've installed have actually been idled. And we have 5 more installations planned for later this year, all of which are going on in as primary mercury sims. Some detail on the installations we already have. 11 of our systems are configured in what we refer to as a local system, in that all the sampling hardware is located on the stacked platform near the port in an even enclosure and with a relatively short heated sample line. And we have 19 systems that are what we call remote, meaning that the bulk of the sampling hardware is actually located in a SEM shelter on the ground and uses a much longer heated sample line to transport the gases from the traps, which are still located up on the stack, down to the samplers. Our longest line that we've installed thus far is 600 feet. So with all these systems operating now, we're getting a chance to see exactly what long-term mercury data looks like. This is eastern bituminous coal, unscrubbed, and you can see that the concentration is in the 4 to 8 microgram per cubic meter range. This is pretty typical of sorbent trap data, with each horizontal bar indicating the single average result you obtain from the time-integrated trap samples, with sample times ranging from a couple days to over a week. Of course, with sorbent traps, you don't see the hourly fluctuations in concentrations that you would see from a SEMS, but you definitely do see that there are weekly, monthly, and seasonal variations. This data is also eastern bituminous coal, but from a scrub unit. Notice that the concentration is much lower, averaging in the 1.5 to 2.5 microgram per cubic meter range. Once again, you can clearly see that there is a trend in monthly time period. And for completeness, here is an example of PRB coal with concentrations ranging in the 3 to 3.5 microgram range. So the question put forward today is, would sorbent trap monitoring still be applicable under MACT? And the answer is, it depends. It depends on how monitoring is defined under such a rule. And if continuous monitoring is specified, would an Appendix K type alternative be allowed? What type of sensitivity would be needed, particularly if controls are specified that would likely drive concentrations below 0.5 micrograms? And would the long-range averaging period from a sorbent trap system be of any use in a control strategy? Probably most importantly, what about the status of mercury monitoring technology when a MACT rule finally does come out? I'm referring here to both sorbent trap systems and mercury SEMS. One of the original drivers for Appendix K was the fact that people were concerned that SEMS wouldn't be ready in time for 2009. So does adding a couple more years help the SEMS? Maybe. Keep in mind, though, that the concentrations being measured may be pushed lower faster under MACT. So which technology is better suited to meet MACT requirements for sensitivity and reliability at really low levels? Clean Air just sold several systems for a plant being built that is permitted at around 0.1 microgram per cubic meter, but it isn't coming online until 2012. Nevertheless, they've decided to go with sorbent traps instead of SEMS because they believe that there are still some issues with the SEMS being reliable at these levels, and that the QA/QC protocols may still be uncertain for SEMS by the time 2012 comes around.